simple domino puzzles. And our supervisor is Hui Yu. In the last semester, we mainly focused on the procedural generation of the card game pushover. What is procedural generation? Procedural generation is a way to generate random game elements using algorithm. Procedural generation involves certain extent of randomness, which brings more possibilities to the game. Pushover is a card game which requires user to rearrange the domino pieces in the correct order, such that the player push all the domino down with only one push only. And the methodology we implement in the last semester in generating the domino level is in reverse generation order. What is reverse generation? Which means that we generate the last domino species first and then generate back to the beginning of the domino species. We use we use these attributes to indicate whether the domino can be put there. The grid of the map, the position of the grid, visitor or not, domino type, forward and direction. And in the last semester, there is a main problem on how to indicate that the level is compressed or not. That's why in this semester, we focus on this topic, which is the experience-driven procedural content generation, EDPCG. EDPCG will player experience as the synthesis of affective patterns in its and cognitive processes generated during gameplay. What is the meaning of this? Is simply we view the one's gaming experience as one of the criteria on generating the game level. For example, whether the player is happy or not, whether the player is interested or not, or he think difficult or not. And there are four major components of EDPCG. First is content quality. Second is content representation. Third is content generator. These three are related to the generator of the algorithm. And the fourth part is the most important one that we need to implement, is the player experience modeling, PEM. Player experience is modeled as a function of game content and player, which means that we try to model and get data from the user to represent his feeling towards the game. There are three main PEM. The subjective PEM, which means that we ask the player directly with some question and questionnaire. For example, I ask you whether the game is difficult or not. The second one is objective PEM, which means that we observe the player, whether the physical player, such as the gesture, the heartbeat rate, or the pupils in his or her eyes. These factors can represent the feelings of one's gaming experience. The last one is the gameplay-based PEM, is the most popular one, which require the interaction between the player and the user, and the player and the system. For example, the time on completing the game, or the reaction when it's failed to meet a target. Because compared to this V1, the objective PEM is the most difficult to implement because it requires some hardware to do it. Therefore, in this semester, we test subjective PEM and gameplay-based PEM. In this semester, our objective is to introduce EDPCG. Second is to improve our domino puzzle games which will consider different attributes in each level. The last one is to complete the game development by introducing more game species and game level control system. These four are the domino species that we have implemented in the last semester, and these three are the domino species that we implement this semester. Here is the pattern of the domino pieces of the new type of domino. This is the tumbler required two generating method. This is the picture and then the exploder. Apart from the domino pieces, we also modify our boundary system. In the last semester, we set up the grid already before the game implement. And in this semester, we did not set up the grid already. And when we generate the game level grid by one, until the total width of all the grid extend beyond the boundary, and then it will stop generating more domino.
So since all the levels are procedurally generated, it is hard to measure the level and measure the difficulty of level until it is generated. Therefore, we have to implement some algorithm to predict the difficulty of levels. So we try to use a mathematical tool, which is multiple linear regression, to model the relationship between a set of variables and the difficulty of the levels. So to implement the regression algorithm, we try to record a set of attributes describing the level. So they are the path length, the number of level, number of volatile, and the number of each type of dominoes. So after we recorded a set of gameplay data, which which uh, which uh, which is these variables with the completion time, we can feed in these data into the regression algorithm to have a prediction on the newly generated levels. After we have implemented the prediction algorithm, we can when doing the generation, we can repeat the generation for a number of times, and we can extract the desired result by comparing their value of completion time, which is predicted by our regression algorithm. So before implementing the regression into the game, we have done some experiment. We have tried both the subjective PEM as well as the gameplay-based PEM. For the gameplay-based PEM, we have adopted the PEM by using the completion time as the dependent variable. So we have tried to use a regression algorithm to predict the completion time of each levels, and it is the result of one set of the data. And as we can see that at the start of the algorithm, which means when there's a little data fit into regression algorithm, the prediction is not that close to the actual time. And starting from about the 15th or 16th turns, the prediction is getting closer and closer to the actual time, which is quite a satisfactory result. So, and there can be exception that you may use longer time in reality, but this exception will not affect the prediction afterwards. So we can conclude that this method is quite a good method to measure the difficulty of the level. So for the subjective PEM, we found that the result is not that good because the prediction is not that close to the actual difficulty indicated by the player. And another problem of using subjective PEM is that the player has to answer a question every time after finishing a level, so the gaming experience may not be that good. So as the result, we have implemented the concept of experience-driven procedural content generation. We are using a regression algorithm to predict the completion time of every generated level to control the timer and control the experience of the players. And we are extending our game by adding more dominoes and using reverse generation to generate solvable puzzles. So here is our demo. Our game has adventure mode, and you can you will start from the beginner mode, and it will generate some level which is in the beginner mode, which means is rather easy to solve. And after each time you solve a puzzle, you you will get some mark, and here is your score. When you completed 3 levels in 1 mode, your mode will be level up. In this case, you will switch to medium mode, which will have a more difficult level generator. And each time, if you fail to solve a level, you will lose 1 heart. When you lose all the heart, you will lose the game. So this is the end of our presentation. Thank you.